Hi, my name is Ken, and this is Let's Code a MUD in C++ 11, Part 8. In Part 7, we created this line-oriented connection class, representing all of our input logic for reading a line of text at a time and then handing it off to our MUD interface. In this part, what we want to do is we want to revisit this start function. We want to revisit this two-step dance we do where we create an object, wait for the socket to be opened, and then start the object. I'd like to be able to do that in one fell swoop. So that brings us back to our server class, where we see we're creating an object so that we have a socket to open. We're opening that socket, and then we're telling the connection to go ahead and start up once the socket's open. And the reason we have to do that is because what we want to do is we want to create the connection here, right, when it's ready to get going, but we have to have the socket ahead of time. So we have to have something like socket type socket, go ahead and accept that socket, and pass it into the new connection. This is sort of the syntax we want to go for. But we can't do this. And we can't do this for the reason of the socket doesn't have a copy constructor. I can't take the socket, create a new one, accept it, copy it into the connection, and then destroy the old one. It's not going to work out like that. Sockets don't have a copy constructor because the destructor needs to be able to close the socket, and then it would be closed for all of its copies, and that would never work. But what socket type does have is it has a move constructor, and when we hear move constructor, we think rvalues. So we're going to spend this part talking a bit about rvalues, revisiting what we learned from part 3 and growing that a little bit so that we can make this in place back here work with moving the socket in. So first, we talked about rvalues in part 3. If you want to go back and review that episode, please feel free. I'll put a link to it in the notes, and then you can go back to it and then come back to here when you're done. But what we learned in part 3 basically was that if you can have multiple overrides of a function on reference type. So I could have some function foo that takes a reference to socket type, or that takes a let's say a const reference. So far we're in C++ 98 land. We're not gone that far yet. So how does this work? If we have a const version of a socket type, it will always call this one. And if we have a non-const one, we'll prefer to call this one, otherwise the const one, right? If this doesn't exist and we call foo with a non-const socket type, it's still perfectly okay to treat it as if it were const. We can cast from non-const to const with no difficulty. But otherwise, we have two overrides, and which one is chosen is based on the constness of the object we're passing in. Now, we learned in part 3 that rvalues introduce a third reference type, which is the rvalue reference type, the double ampersand here. And what this means is that an rvalue, or an rvalue, which is the return value of an expression, some kind of temporary, like socket type here, will prefer to call this one, otherwise the const one. So if this doesn't exist, the const reference type is perfectly willing to accept rvalues, but if we have both, rvalues will go to the rvalue version. And that's how we're able to distinguish between a copy constructor and a move constructor. A copy constructor will have const reference type argument semantics, and a move constructor will have rvalue reference type argument semantics. So let's look at that again in a slightly different way. Let's say I'm down here. I've got my socket type socket, right? And I'm going to call foo with it. So which version do we get here? Here we would get foo of socket type, a regular lvalue reference. Now, if we had some const socket type socket2, which one would we get? Again, that should be pretty obvious. We're going to get foo of const socket type, right? This is a const lvalue reference. And then if I called foo of, I created a temporary, I created an expression here. This is going to call rvalue reference, right? This is an rvalue reference. Okay, but you may have a situation where you have an lvalue, but you want to treat it as a temporary. You want to treat it as an object which you're okay with the consumer mucking with it treating as if it owns it. In other words, moving. We want to be able to move the information from this lvalue into a new object. And the way we accomplish that is with a cast, an lvalue to rvalue cast. And we use the function standard move to do that. So if I do this, this treats socket as if it's an rvalue. This is lvalue casted to rvalue. Cast, what's the past tense of cast? We'll say casted. We had an lvalue, but we cast it to an rvalue. And so we're able to get the rvalue version of it. So that's great. That lets us move from the socket. Let's get socket 2 out of here so we can see it clearly. Let's look at the comparison between these two. So we could call the lvalue reference type, or with using standard move, we could treat it as an rvalue. And it's okay to move. So this controls whether we get copy-like semantics or whether we get move-like semantics, basically, right? Okay. So how do we do this in practice? How do we apply this knowledge? Well, so what we want to do is we want to be able to move this socket into the connection. So we're going to want to be able to do standard move socket. Yeah, that's great. Now, we have a small issue here, which is that by the time this handler gets called, we've actually already finished the accept method, so socket's going to drop out of scope. We're going to get a seg fault. So we need this to be a class scope, so it exists when the callback is called. So let's just go ahead and move that into here. TCP socket, and this will be msocket. Actually, let's call it next socket because that means something. It's the next socket that we're about to open. So we're going to say we want to accept the next socket. That's already part of this, so we don't need to capture it. And we're going to move in that next socket to the connection class. Let's see if this compiles. It shouldn't. And it should be obvious why it doesn't shortly. Oh, first we need to initialize mnext socket. Mnext socket we're constructing with a default constructor, which doesn't exist. So let's just initialize that up here. Next socket mio service. Okay. And then we'll try and compile it. What error are we getting? We're getting no matching function call to line-oriented connection with a stream socket. Right, so we haven't updated our connection classes to be able to take in a socket or even an rvalue to a socket. So if we look at here, we're going to need to update this. We're going to want socket type, and we're going to want socket type with an rvalue reference. Remember, we're only accepting sockets as long as we can move them. We don't want to try and copy them. So we'll pass that in, and let's get the base connection class. Again, socket type, rvalue reference, and we'll initialize that here. Let's compile it. Okay, we have one more problem. What's that problem? Use of deleted function, basic stream socket, const boost basic stream socket 1 ampersand lvalue reference. So it thinks we're trying to call the copy constructor for socket, even though we're passing it an rvalue reference. What the heck is going on here? Why is that the case? Well, I hate to jump to crazy town. I hate to blow your mind, but an rvalue reference is in fact an lvalue. I know. As soon as we gave it a name, it actually became an lvalue. We started talking about an object that lives somewhere. It's no longer a temporary. It's some object that we have a reference to that lives somewhere. So even though we know it's a reference to an rvalue, it happens to be an lvalue. So how do we cast lvalues to rvalues? Luckily, we know how to do that. So standard move. And you're going to see that a lot. This is going to be a common pattern in constructors. Whenever you take an rvalue reference in a constructor and you want to move it somewhere, you're going to have to do standard move. So you're going to see this pairing of rvalue reference and standard move a lot. And then we'll go down here, standard move. Okay. Now this should work. Okay. And we're going to do one little thing because we're not calling start anymore. Remember, we're only creating the object, and we're going to let that do all of our initialization. So let's trim that, and let's try to run this. And while we're here, let's put a little friendly message here, just saying, you know, we've opened the connection. Let's write welcome new user. We'll move all the friendly stuff into the interface class when we start writing the interface class. But I want to see a prompt. I don't want to see just a blank telnet screen. I want to know that the connection was opened. Okay. So let's run the program, and let's telnet to it. Okay, see it says welcome new user, although we should have put an end of line. So here we go. Close. Okay. We should have put a new line here. Let's go ahead and do that. Okay, run the program, telnet into it. Okay, now we have our own line. Let's say, hello server. And we'll come over here and it says received line, hello server. Okay, so our reading and our writing is working fine. So that's all I wanted to do in this part, was to explain how to use rvalue references to accept a movable object in a constructor. And let's review how we did that. So we called our constructor by casting an lvalue we have down here, which is some member variable to a socket. And we cast it to an rvalue. We said it was okay to move from it. It's okay to clobber it, to treat it as if it were a temporary. And then we passed that in to a constructor that took an rvalue reference, and we had to, in order to use it as an rvalue, we had to cast the rvalue reference to an rvalue. I know that's so painful, but we did it. And then in connection, we did it again, and we used that rvalue to construct our socket type, our msocket. So we were calling the move constructor of socket. So I think that pretty much covers our second look at rvalues of using the standard move function. And now we have a much more friendly connection class that doesn't need a start method to be called. Whenever we construct a connection, we now have a guarantee that all of our connections, once constructed, will be in this open state, and we can do anything to them. We can close them, we can write to them. Anytime we see a connection, we now have a guarantee that it's opened, and that's so much stronger from a type safety point of view. So I hope you appreciated that. We're going to move on. We're going to talk about closing connections in the next part. But until then, my name is Ken, and this was Let's Code a MUD in C++ 11. Thank you for watching.